All right. I was really inspired by Bob Scully's talk yesterday about future of payments on the internet, potentially using ecash, especially the part where it's about equipping agents with means to pay. So I thought one way to go about this would be using data vending machines with ecash on Nostr, which data vending machines are defined in NIP 90. Most of these implementations for agents and paywalls are using L402, and I thought in this case we could use Nostr as the railways and ecash for sending money back and forth. Real quick, what are data vending machines? They are defined in NIP 90. They can be used for requests for data processing, search requests using LLMs and so forth. The user requests a service. Data vending machines bid on the offer, quoting prices, and then the response might come back with a payment required, which in L402 would be 402 HTTP header. But we can do the same with ecash, I think. So this is the quite complicated flow using the L402 implementation. And why not just send ecash instead over Nostr to an npub, the npub of the data vending machine. The spec mentions the Bolt 11 Lightning invoice here, and we could just replace that with sending, requesting an amount, let's say 1 set, for processing the data, and then sending the ecash token back, and maybe also the data vending machine could suggest a mint so they don't get rugged. Actually, thanks to SuperTestNet for that suggestion around the mint specification. So the alternative flow that I'm going to show you in a second works a little bit like this. The customer requests a job, which is in Nostr a node of kind 5000, and then the data vending machine bids on the job with a payment required response. The payment comes, the customer pays with ecash. Okay, and I only have 1 minute, so I'm going to speed this up. Just go straight to the demo. The final step anyhow would have been the job result. So the demo is pretty hacky. You just have a customer and a DVM connecting to the relays. The customer sends the job request event over Nostr, and then the DVM responds with the send payment required event, which would have been the 402, saying the amount is 1 to process this. It's 1 set using ecash, and then the customer says, okay, here's the ecash, send job payment event, and there's the ecash in here that's assigned to the Nostr npub, and then the DVM actually performs the job. So in this case, we want to do a search. We want to search Nostr for the term ecash, perform the job. These are the search results, people speaking about ecash on Nostr, and then I'm going to send the results back to the client. And that's it. Thank you very much.
Excellent. Thank you. Questions? Questions from the judges? No, we're good. Okay, excellent. Thank you very much, sir.
Thank you.
Up next, number 4, Kickstart CLN Core Lightning eCash plugin.
So yeah, I built a little plugin for Core Lightning. Core Lightning has this convenient plugin system where you can write small applications that communicate with Core Lightning over STD in and out. And it's a plugin with a ecash wallet using CDK. And it's essentially, maybe some of you are familiar with the model of PhoenixD with this fee credit, so you can receive even if you have no incoming channel and the incoming payment is too small to create a channel or to pay for a channel from a LSP. So it collects a small ecash balance, so you can set up a completely new Core Lightning node without any channels, create a small invoice, you can receive SAPs on Nostr, and then it just collects the balance, and once a threshold is reached, it will request a channel from a LSP service provider. So like, for example, the Olympus LSP from SUSE, and it will open a channel. Oh, it's not visible. And Yeah, and so you essentially always able to receive payments, and shouldn't have failing. Oh, okay.
Extended screen, so if you want to see what's on. Your timer is paused, by the way, while we have these minor technical issues.
It's working now. Yeah. Okay, I will give a quick demonstration. So this is the MutinyNet Bitcoin core node running. Then I will run a Docker container with the Lightning node, with core Lightning. So you can see it's running, and here's the plugin logging its output. And the Lightning node currently doesn't have any open channel. You see there is already some ecash balance, like 28,000 sats here. And the cost for opening a 1 million sat channel is 34,000 sats. So it will just create, so if I use it hooks into the invoice creation API command of core Lightning. So this is the command to create an invoice. It's also being called by third-party applications that access core Lightning. And you see this is now a ecash mint invoice. You can see it by the index 999. And I can pay this from the MutinyNet faucet. It's been paid. So now now it does an API request to the SUSE LSP and tries to pay the invoice. And then in theory a channel should open. I had some problems with paying the invoice. Yeah, it's not paying the invoice because there's some liquidity problems on MutinyNet, but I can copy the invoice the LSP sent to me and pay it with the faucet, and then it should open the channel. Yeah, there's the invoice is created by the Olympus LSP. Sometimes don't work. They sometimes have incorrect payment details. So it's not completely working, but it's the concept, kind of. Yeah, it should open the channel now, and it did work sometimes. Okay, yeah, that's essentially it. Do you have any questions?
Judges.
Yeah. So do I understand it correctly that while you don't have enough money to open a channel yet, then you receive ecash in some mint, hold it there, and then eventually you have enough ecash to open the actual channel?
Exactly, yeah, and then automatically opens the channel for you. So I also made it so it's really easy to set up, so you don't have to do any specific settings. You can with environment variables, but it should be very easy for the user to start. So it just sets up the plugin and it does everything with a default mint and default channel size.
Excellent. Thank you very much. That was Cashew Agents. Up next, number 6.
So my project's called Cashew Agents. Sounds like I should have worked with Rob on this one. I didn't implement the DVM spec, but kind of same concept where we have AI agents that will pay each other with ecash. So the basic idea of how it works is I have a chatbot and a generative AI bot running separately, and the chatbot will generate a prompt that then it will send over to the image generator, and the image generator is going to charge some ecash, and if it gets the ecash, then it'll generate the image and return it to the user, and the two models communicate over Nostr. And so the basic flow is that the user inputs any prompt that they want, and then the chatbot will request 100 sats, mint those as ecash, and then send those over to it'll get the 100 sats of ecash, and then it will generate a prompt that is kind of specialized for generating an image. Add some more details to make it look fun. And then it'll send the request over Nostr to the image generator AI, and then we'll get the image back. So the only thing that I had done before this was a Next.js hook that just kind of gives me some Cashew wallet functionality. So I use that to receive the Lightning payments and hold my ecash balance. Okay, cool. So I got this tab here. So these are running the same service pretty much, but on I started up 2 different instances. So this is the chatbot running on port 3000, and this is the image generator running on port 3334. So you can see the image generator has a public key, and currently in its wallet it has 0 sats. So I'm just going to copy its public key and put it in over here, and then I'm just going to give a basic prompt, and it's going to, using the testnet mint, so should just get paid. Now it's fetching a prompt now that it has 100 esats, and it didn't work. Not enough relays received the event. So I was having some very weird problems with Next.js where all of a sudden the page isn't found, so I have to restart my server. Try this one more time. All right. Let's see if this works. Again, mint 100 sats. All right, there we go. So it sent the prompt over, and now we can see this is processing. Waiting for the response as it generates the image. And then we get it, and this guy over here now has 4 sats, so it's a big markup. We paid 100 sats, now made a massive profit and generated this image for the user.
Amazing. Judges, any questions? One question, Eric Surian.
So some of these models, I think they don't really know how much it will cost to generate content ahead of time. Like, do you implement any refund logic in that case?
No, not at this point. I just kind of arbitrarily send some ecash and haven't gotten to the protocol side of it yet.
Yeah, it just means more profit.
Yep, exactly.
Thank you very much. So that was Cashew Agents. Up next, number 6, Fediment Web.
All right. Yeah, after seeing all the other projects, I really need to think about naming things better. This was after 2 hours of sleeping last night, so I couldn't really think of a good name. So why did I just do that? All right. So wouldn't it be cool if you could interact with Fediment through a browser extension directly from your browser? Well, great mints, by the way. Well, I thought that was pretty cool, so I then proceeded to spend the next 20 hours in NeoVim, and now we have a live demo. It didn't turn out the way I wanted it to completely, but it works in some ways. So I need to zoom in quite a bit so you guys can see. Nope. I can't really find a way to increase the size. So first I'm going to install the extension I've created, and it opens up over here. I spent way too long on this opening animation. So the onboarding process is fairly simple. You hit getting started, you join a number of Fedimints, and you enter your Nostr secret key. I'll just paste that in right there. And now this is the wallet UI, so you can switch between the one you're using, and you have a number of functions to to interact with Lightning and ecash payments. On top of that, similar to a bunch of other browser extensions, you get to, let me refresh the page. We have little pop-ups where you can confirm signing messages, approving payments, etc. Not all of these are completely functional, but I did create a UI for all of them. So yeah, this is the concept, and that's about it. Thank you.
Judges, any questions? We're all good. Thank you very much. Up next, we have Nixify hash pool. That's number 7. And number 8, Clams, can you please report to the stage area?
All right, so our project is to Nixify hash pools. I have a really hacky Stratum v2 setup to start testing hash pool, which is a mining pool that uses ecash. So the prior work was that, and I used to open up like 6 different browser tabs because there were 6 processes to run. There were 4 Stratum who helped me set up a Nix Flake that was untested. That was at Noster Hack Day. So that's all prior work. And then once the hackathon started, we hooked up with Gotcha, who is awesome, and got a Nixify shell set up. So I'll get it going here and explain what it's doing. Right, so here you can see our 6 processes: bitcoind testnet, Stratum job client server, Stratum job server, sorry. This is the actual pool itself. Here's the CPU miner. It's all starting up right now. And what the proxy does, proxy is the only thing that's doing any real work right now. It generates half of an ecash token when it receives a valid share from miner D. So here we see miner D is starting to produce some hash rate. You can see the zeros at the beginning. And here, if we watch this scroll, we'll see some blinded tokens pop in eventually when it finds a valid share above the pool difficulty. So, Gotcha, would you like to explain all of the nice benefits of the setup?
So very quickly, I have been fighting with Nix for a very long time. I'm still a newbie. And the reason I'm really excited is because we built this with devconf, which is a tool built by the Nix community to help you set up development environment. And so, for instance, setting up those processes was really, really easy once we got the building of those specific branches that VNRPC just mentioned. And so that's one thing I wanted to stress.
Blinded token, here we go, baby.
And the second thing I wanted to stress is that it was a community effort since we started with Julien. I asked questions to Shorts, to Stick, to Eric, and so on. So this was a chance for me to suggest to anyone, when you come to such a hackathon, just try and do it. People are really nice and approachable. And that's it.
Thank you very much. Judges' questions, Eric Syrian.
That UI looks super slick. What are you using for that? Like that the test these multiple tabs.
That's Process Compose.
Awesome. Thanks.
Thank you very much. That was Nixify hash pool. Up next, we have Clams, number 8. Number 9, please report. Testnet 4, reorg, min difficulty pool.
All right, cool. So yeah, if anyone doesn't know Clams, we're John and Aaron, and we're building accountancy software for Bitcoiners with privacy at its core. So just a little bit of quick background on our app. It's a native app, and you pull all your Bitcoin data into one place, and then you can make better decisions, eventually generate reports. We're working on that feature right now, and do forecasting, and all at the same time maintain your privacy so you don't have to dox yourself to the likes of QuickBooks or Coinly, these types of companies. So we have CLN, LND support right now. We have on-chain, multi-sig, and Noster Wallet Connect. And then, obviously, this being an ecash conference, we thought, how would ecash accounting work? not particularly easy, we learned, but we thought NIP60 could be a good place to start. And we learned about this from a presentation from Calvadev, the Shopster fella. And yeah, essentially every user has an event that represents their wallet. They have events that represent unspent proofs of their wallet. And then they have events that represent the spending history of the wallet. So this spending history is what Clams is interested in. So we can start there. So I have a couple of Shopster wallets here. And this one here, you can imagine just as someone running a business, they're selling some goods. And I'll go ahead and bring this user's MPub, or their NSEC, I should say, over into Clams and see if we can pick up the data, and then we can talk through it. So I'll jump over to, I'll grab their NSEC here. And this is the Clams app here. So as you can see, these are all your options. And part of this hackathon, we added Cashew here. So I'll add a label. Let's just call it My Shop. Drop in their NSEC. And then here we've just hard-coded the Damus relay because we know we posted the events there. But the user could specify maybe their own relay. They only want those events hosted there. They can do that. So we've got the connection now in place. And we'll go ahead and kick off a sync. And you can see we have, it's picked up that it has 11 sats. It's given them their cost basis, the current market value in fiat, in the fiat realm. And so if we jump over here and grab a token from this other Shopster account, we'll go and just receive one here. See if we can pick that up. So the token has transferred. We'll now, this connection has been formed. So every time you open the app, you don't have to do that setup. You'll just come back to your app, you'll resync, and you can see now the balance over here is 12 sats. So we'll jump back here and talk a little bit more about how this works under the hood. So obviously, we have to ask the user for their NSEC and their preferred relays. Clams decrypts the content of each event using their NSEC, and then we, under the hood, convert all that metadata into double entry bookkeeping format. What's next? Ideally, we wouldn't be getting asking users for their NSEC. So in theory, we were thinking we could look at something like NSEC Bunker. So we get the events we're interested in, and then we ask NSEC Bunker to decrypt them for us. So that's it. Yeah, you can learn more about our project if you're interested at clams.tech. Thank you.
No questions from the judges. Thank you very much, Clams.
Right.
Up next, we have testnet 4 reorg min difficulty pool. And please report to the stage, Munt.
All right. So unfortunately, we didn't really have a good idea for something with ecash, but since we're here and hacking something, we thought we would just try to do something useful. Something that is supposed to be useful is testnet 4, better version of testnet. Testnet 3 was kind of exploitable with the dreaded block storms, and there was a fix for that in testnet 4, which basically sets a limit to these minimum difficulty exception blocks that you can mine. But because this conversation was kind of out in the open, I think a couple more people that are spammers or scammers, depends on what you want to name them, they exploit basically this to the limit, which then again means that while you can still use the blockchain, you cannot use this feature as basically a way to get minimum, get non-standard transactions into the chain, which is really the whole goal of this. So what we want to do, the people that annoy us, we want to annoy them back, basically. So since they annoy us with minimum difficulty blocks, what we can do is we can reorg them. And that was something that was already an idea that we had when we worked on testnet 4. But we just hadn't done it yet. So now we have a modified Bitcoin core, which when you call a template, it rolls back the blocks and throws out all of these minimum difficulty blocks and instead builds on the last actual difficulty block. So then the idea is that we can run a pool on that. I had started on the code, and then thankfully I found MZ, who happened to say, oh yeah, you need a pool, I have a pool. And then Shores was like, yeah, you need a miner on the pool, I have a miner. And so yeah, we set up this modified bitcoindev, which is providing the templates. We have a pool that is providing this to mine on, and then we have a miner which is now heating up Shore's apartment a lot, trying to annoy the scammers back. Yeah, that's it.
Amazing, thank you. Questions, Nifty.
Are you guys planning on shipping this as a fork or making it as a PR, or is it just a fun stunt? Activated soft fork.
I'm not sure if it's supposed to be in core, but as long as we have this pool publicly available, like anyone who wants to be a good citizen on testnet 4 can just mine on that pool, and then that should fix the problem.
And the pool is currently available, like launched and live, so people can join it?
Not fully yet. I think we need to do some cleanup, and then we will publicly available.
Great, thanks.
Thank you. That was testnet 4 reorg min difficulty pool. Up next, number 10, we have Munt. Please, a warm welcome. And number 11, multiple payment vault 12, please report to.
Hello. So we have ecash. We want to back it up. Let's just get to the demo, because why not? So you see there are two browsers here. They are completely independent of each other. And there's a server that can like store encrypted blobs with like key values. So you will see that these two have the same root mnemonic, like this one and this one. And if you like, they have the same balance. So let's say I will send it from the left-hand side. Send one sat, because I'm poor. And you will see this balance is updated. And I click refresh, and the other one updates. And I can steal this note. Using my phone. And it is in the wallet. Now we'll try to receive it from the other side, like the right-hand side. Give it permissions and all. Send it from my phone. And this updates. Now what I'll do is I'll not refresh the other one. And I'll try to send it from the other one. And I'll send two sats. So what should happen is the balance should still refresh. And the final balance on this thing would be one sat. Now I can refresh this one again. And it will become one sat. And I can still, like, they can be really concurrent and they don't conflict with each other. They use locking on the remote side. And everything is encrypted and signed in the database.
Thank you.
So we can like look at how it works. Like you have get requests where you get a value and a revision. Then you have an update request where you have to pass the old revision and the new value. If the revision matches on the server side, the server will acknowledge your update and update it in its database atomically. If it doesn't match, it will just reject the update and send a NAC. And you do this get again on the, like you can see on the client to the first update field, it did a get again, tried the same operation which is like consistent, that can like almost like a CRDT in a way. it like synchronizes the sets of ecash you have. And it does the update again. And now this time the update passes because you send new data, but this time you acknowledge that you have seen the revision one already. Yeah, that's all. Any questions?
Really cool. Like one question, can you still use ecash offline that way?
You have to, it is possible that you can just remove some ecash from the server, like reserve it offline. But because of how it works, you have to do locking on the server side. You can't use all the ecash offline, sorry.
Thank you very much, sir. Oh, sorry. One more question.
Amazing work. Can you also can you coin select on the server? Are the amounts open, or is everything encrypted in a single blob or multiple?
Everything is encrypted in a single blob and padded, so server doesn't even know how many coins you have. And coin selection happens locally. You have a set of coins, you remove it locally like this update value operation, and you update the new set on the server.
Yeah, thank you.
Thank you very much. That was Munt. Up next, we have multiple payment Bolt 12. Please, a warm welcome. Number 12, HTLC rebalancer. Please report to the stage.
Is this on? Yeah. This is a pretty simple one after that, especially. It's just to pay multiple, so you can pay, you get a Bolt 12 offer from the mint, and then you can keep re-minting to this same Bolt 12 offer. So like the use cases, you can generate a Bolt 12 offer in a Cashew wallet, post that publicly, and then that can be donation or whatever, and people can keep paying to that, and you can go offline, and then later you can come back and mint your ecash related to that Bolt 12 offer. So, oops, I'll just generate, so this generates a quote, and I haven't bothered to do QR codes, so I'm just going to post it to Nostra, and then hopefully it'll show up. And then, so I'm just going to my Phoenix wallet here, since it supports Bolt 12, and I'll pay myself, and hopefully, so that goes through. So that's the same flow as now for a Cashew, where you get that one payment. But the interesting part here is I can do remint. So I can just get the quote ID again. So the wallet could be doing this in the background, or every time someone opens the app or whatever. This will actually fail because I haven't paid myself again, the offer again, right? So there's no ecash to issue. But if I pay myself again, another 10 sats, seems to have gone through, and now I try to mint again. It's a bit slow in here, but hopefully. There it goes. So you get your tokens again, and so you could keep paying to this Bolt 12 offer as many times as you want, and just every time you can check in with the mint to see if anyone's paid it, and then mint the ecash for that token. Yeah, I mean, that's pretty much it. It's a simple one.
Thank you very much.
I have a quick question. So just so I understand, you're paying a Lightning invoice, and then the money hangs out in Lightning, and so you come to claim it. Is the HTLC actually claimed? Is the money sitting with the node?
The mint claims it. So the mint claims it, and then just the mint basically tracks how much has been paid in associated with that mint quote versus how much ecash it's issued. So if it's received more than it's paid, it will mint the next time the wallet attempts to mint it. And hopefully it never goes the other way, and where it's paid out more than has come in.
Cool.
Yeah. So the Lightning part is totally online with the mint does that. Yeah.
Oh, okay, that makes sense. Thank you. Cool.
Thank you very much.
Yep.
That was multiple payment Bolt 12. Up next, we have HTLC rebalancer. Number 13, eTime Bank. Please report to the stage.
Okay, this is a simple demo for, well, not a demo because it doesn't work. Turns out that 90% in the development process, I noticed the wallet library I was using doesn't have HTLC availability, so it's an easy fix. Didn't have the time to fix it. How this works would be pretty simple. I have here a network that it's very simple. I'm connected to Bob and to Carol. Bob's gonna do most of the work. But what happens behind the scenes is this: like, Bob receives an invoice. It will check it will hold the invoice for a second, check if there is enough balance to transfer the payment, to continue the payment. If there's not, it will message his channel partner with a custom Lightning message to see if he's willing to exchange some ecash that would be locked to both. It would be locked to the same pre-image as Bob will give Carol so he could pay, and it will be also locked to Carol's pub key. That way, only Carol, once the payment happens, is able to reclaim the ecash. That's why it's more atomic. We can see the structure here. We basically have a lock type HTLC to the pre-image of the invoice. You only need one signature from an available pub key, and in the case that Carol actually is not participative, there's an expiration. There is a lock time that's a little bit higher than the expiration of the invoice. That way, we can claim back the ecash if we wanted to, because in the refund area, it's Bob's public key. So yeah, it's a good way to avoid problems. So now I will connect to the service. Up it's Bob, and down is Carol. So we just connected, and I'm gonna make an invoice, right? So I will create an invoice for Carol, right? Right now I have commented out the part that analyzes if the channel is bigger or lower, just because the demo is easier. It's just to comment out that in reality. And I will pay the invoice. If I pay it, you're gonna see that things start happening. It will flow through because it's not ready, so it will just flow through. So you will see that Carol here down received a custom message for 2069, and it says that your partner wants to give you not. And he will take that amount, analyze it, see if it's possible, and it will return if it really wants to go ahead, it will return Carol's pub key. So, and this is where I had to stop because I didn't have the time to fix it. Now, but what it would do is create the ecash, right, and send it back. And if everything flow and send it back, now Carol would pay the invoice that I would give her, because during the exchange, I'm also sending an invoice. During the exchange of ecash, I'm also sending an invoice for Carol to pay. And if Carol pays, she takes the ecash, I take the balance, and now I route the other invoice it's on hold, and we're all happy. The Lightning Network works. That's it.
Thank you very much, sir. No questions from the judges. Thank you very much. So that was HTLC rebalance. Up next, we have Lightning Welder.
Check. Checking the mic. Great.
Super. Just by the way, it is a 5-minute thing, not a 15-minute thing. All right.
Got it. We got it.
Hey, everybody. Welcome to Lightning Welder. I'm Alex Lewin.
I'm Super Testnet, a working man.
And we have a project called Lightning Welder. We are making, the goal of this project is to make Bolt 12 offers backwards compatible.
If you can pay a Bolt 11, you can pay a Bolt 12.
So, some background. Bolt 12 is the future of Lightning. All the cool people know this. It has some amazing privacy properties, like private withdrawals from custodians. Basically, all the protocol engineers in Lightning agree this is where the industry is going, this is where the technology is going.
99% agree, and the other one's an altcoiner.
Wrong, yeah. And there's lots of efforts to support this. LDK, LNDK, CLN, and Claire have all dedicated significant efforts to supporting this protocol. So, why aren't we all using Bolt 12 offers all the time? Well, it's complexity. The application tooling is lagging significantly behind. In order to implement Bolt 12 natively, it requires a piece of tech that's more complex than basically your entire rest of your stack.
It's tough to be a dev.
And so This is a massive mountain to move. But what if? What if we had a bridge that is completely trustless and perfectly private?
Can you imagine the future of the Lightning Network?
Absolutely. If only there was a protocol like this, and there is now. It's called Lightning Welder, a lightweight vanilla JS library and bridge between Bolt 12 and Bolt 11. Let's do a demo.
Future is now.
So as I show you this demo, Super Ron, explain how it works.
This is my phone, and it has a 252 sat balance, running Phoenix, which means it supports Bolt 12. The 3 secret ingredients to doing a bridge between Bolt 11 and Bolt 12 are the amount, the lock time, and the payment hash. If you can get those things from a Bolt 12 invoice, then you can create a Bolt 11 invoice with the same parameters, show that to the user, and then the user knows, hey, if I pay this, I know that he can't settle this payment unless he gets the pre-image to the Bolt 12. How does he get that pre-image? By paying the Bolt 12. So he's going to do it just now, pulls up my phone, my balance, clicks weld. It shows him the the Bolt 11 Lightning invoice. So now he's going to pay that using an ecash wallet.
Yeah, Callie, does cashew.me support sending to Bolt 12?
Correct.
Wrong answer.
You're wrong.
So wrong.
It does.
It does.
Any wallet that can pay a Bolt 11 now can pay a Bolt 12. My balance is 252. The payment is routing. The node has seen it. It has now been accepted. And voila, 272 sats. I know you guys can't see it, but it says it. 272. Paid.
Can someone please verify that from from someone from the front row? Can you verify that?
And a cool nit with this is this paid message showing up from the client. It's actually not the Bolt 11 message being paid. It's the validation that the Bolt 12 offer is completely paid from the service provider, and the client can verify that yes, indeed, the intended recipient has their money.
You have the pre-image. You have the proof of payment. You can get your pizza. Let's do it.
Fantastic. So that was the demo. Oh yeah,
Amazing.
try this out. This is live. Go to tinyurl.com/lnweld. The outcome is we have a perfect a bridge between Bolt 12 to Bolt 11. It is perfectly private due to Nostr.
The server doesn't even learn your IP address, folks. We are talking perfect privacy.
And uses ephemeral key, so there is zero traceability between usages. And we have an easy, dead simple implementation for Lightning or for any existing wallet. So tomorrow you will wake up and have all of these features. To do next steps, we got to polish the library code. This is a hackathon. And
there's a few bugs. There's quite a few bugs.
Yeah, there's bugs. Release the server.
Server can steal your money.
Yeah, we got to bundle. We got to bundle and release the client library. We're going to shove in the Fediment Web SDK because why not? And we're going to bring Bolt 12 to every single Bitcoin wallet. All code is free and open source.
Amazing. Thank you. Some questions from the judges.
I think you guys just covered this, but so it's not live currently, so I can't go use it today.
It is live, and you can go use it right now.
I can use it today, and the downside is I might get rugged.
You might get rugged because the client's not validating the signatures on the invoice, so he needs to do that. But it's in progress.
Okay, but it's usable today.
Yep. GitHub. Go to GitHub. Alex lwn123.github.io/lightning-weld.
I only have 50,000 sats on the server, so make small invoices.
Thank you.
So, ladies and gentlemen, that was Lightning Welder, and that was the last of our streamed presentations. There are some private presentations still to be made.